So this video describes what is logistic regression and how to build a logistic regression model for one of the data set that we are going to take, that is Titanic survival. So first of all, what is logistic regression? So this algorithm falls under supervised machine learning and specifically classification algorithm. So supervised machine learning means what is to be predicted is already there in the training data set, and we have to make the prediction once the model is built for the test data. So it's a classification algorithm with one or more independent variables which determines the value for outcome. And importantly, this algorithm is applied when your target variable has the value like 1. You can consider that as true, 0 for false, and in some other cases when your outcome is like yes or no, or fake or no fake, binary classification. Or this can also be used for multiple classifications, like for example types of forest. So there can be multiple types of forest values, that means more than 2. So this algorithm predicts the probability of occurrence of an event by fitting the data to the logistic function. So you can fit your data to the logistic function, and then finally it gives the probability value, and you can set a threshold, and that threshold determines the value is going to be either 0 or 1. So this is an equation for logistic regression. Logistic function beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 up to beta n xn, and x1 x2 x3 and up to xn, these are variables from your data set. Beta 0 is intercept, and then beta 1, beta 2, beta 3, these are the coefficients of variables. So it gives the probability, and by the probability value you can determine the value is going to be either 1 or 0. So the probability of success is indicated by p, and probability of failure is 1 minus p, and this value is always no be positive. That means p is greater than or equals to 0 and it is less than or equals to 1. That means the probability value lies between 0 and 1, right? The probability value lies between 0 and 1. For example, in order to know whether the customers will buy a product or not, so this is the binary classification problem. You need to determine the customer will buy a product or not. Yes or no type of outcome is expected. And here but the dependent variable is binary, which has only two values. So in case of graphical representation, the difference between linear regression and logistic regression is linear regression will give you the straight line, whereas when you project data with logistic regression, you are going to have a S-shaped line, sigmoid curve. And these are the types of logistic regression. First one is binary logistic regression, where you have only two outcomes like good or bad, yes or no. Then another type is ordinal logistic regression. Here you have more than two outcomes like high, medium, low, um, strongly agree, disagree, strongly agree. So you have more than two values for the outcome. Next, there is also one more type, that is multinomial logistic regression. It means it is here also we have more than two outcomes, but the values are in order logistic regression, the values are ordered, whereas in multinomial no need to maintain an order, like type of forest, like evergreen forest, deciduous forest, rainforest. So we have more than two outcomes. So remember, there are three types of logistic regression. Binary means you have two values, ordered means more than two and the values are ordered, and multinomial means more than two, the values are need not to be ordered. Then how do you evaluate the performance of logistic regression? So it can be done like these measures. AIC, which stands for Akaike Information Criteria, and it is one of the standard metric which measures the fitting of data. Measure of fit which penalizes the model for the number of model coefficients. Normally when you have more coefficients, then the it penalizes the model. So the minimum AIC is the better value. And null deviance and residual deviance. Null deviance means the response predicted by a model with nothing, means no input is given. So this value is to be lower, right? Lower the value, better the model. Similarly, a residual deviance, so this value has to be also lower, which indicates the response predicted by the model on adding independent variables. So if you add more variable which also affect the model, so you can have a better performance. But normally, even though the number of independent variables are added, the error value should be lower. And then confusion matrix, of course, for classification model, you can see the confusion matrix, which presents the actual versus predicted values. So you can have a tabular accuracy of the model, and by avoiding the overfitting, like the accuracy can be calculated from the table, like actual have two values, negative, positive, and if you consider the same as a column, negative, positive, so you need to find out true positives, true negatives, false positives, and false negative. So from this you can calculate specificity and sensitivity. So specificity means, in other terms, we say true negative rate, which is equals to here a by a plus b. Then what is a? A is true positive divided by a plus b, which is nothing but true positive plus false positive. So the sum of this specificity and 1 minus specificity, so both should be equals to 1. And then sensitivity is nothing but true positive rate, TPR. Here it is T, true negative rate, which is equals to d by c plus d. D means true negative divided by c, false positive plus true negative. So here also sensitivity and opposite to that, that is false negative rate, sum should be equals to 1. And in addition to the specificity and sensitivity, so there is also one more measure, that is ROC curve. So ROC curve also determines the fitting of the data. So like you have the curve like in this way, and below the curve you can have the metric, that is AUC, area under curve. So if the majority value is fitted, then it is better. So model will learn from more data. So it is learning properly means it is going to give you the predictions correctly. So you can determine the probability value greater than 0.5 indicates the success rate, that means 1, less than 0.5, which we consider that as 0. So maximum data is fitted. So when you fit the maximum data, you are going to have a S-shaped curve. So this is the positive area where it is shown that maximum data is fitted. So ROC is also one of the metric to evaluate logistic regression model. So here we are going to take a data set, that is Titanic survival, and here the outcome is who is survived and who is not survived. So I'll take you to the R studio, where I'll be demonstrating how the logistic regression model is built. So at first we are loading the data. So we have train and test data as well. So train.csv and test.csv. So using the read.csv function, we are loading the data, and then header equals to true means the data set already has no column name, so that's why header equals to T, means true, and missing values are identified as empty with no value. So we'll be loading the train and test. So I'm just running these two lines, then two data frames are created, and you can see that in environment variable, train has totally 891 observations and 12 variables, means 12 columns. Test data has 418 observations, means rows, and 11 variables. So remember, test data always has one less variable, because you do not have the target variable in test data, so which has to be predicted. Next, I'm checking for missing value. So by using the sapply function of R, so sapply of train, so we are defining a function which returns as is.na.x. So this will give us the missing values in the data set. So as you can see, Ace has 177 missing values, and cabin has 687 missing values, and embarked has 2, and our target variable is survived. So we have to make a decision who is survived and who is not survived. And this Amelia is one of the libraries, so if you do not have, then you need to install it, and after the library install, you need to import so library of Amelia, and this is going to show us the missing values graphically. So the function is mismap of train data, and this is going to be title. And when you run that, right, when you run this, you can see the function. So here I'm going to just zooming out. So you can see Ace has missing values, that's why you can have horizontal white lines, and cabin has many missing values, so that's why so many horizontal lines. And you can consider one more variable, which is embarked, which has only 2 missing values. Here it is not that much clearly shown. Yeah, it's shown now after zooming. So here is one observation which has missing value, and here is one more one which has missing values. So that is the use of the library Amelia. And if you look at this train data, so no machine learning algorithm is going to learn from unique values. So every person has a unique name, so we just remove this name, and also this one, yeah, name is removed, right? And then age we can consider, and also gender we can consider. So what we are doing is we are selecting these, the column names 2 3 5 6 7 8 10 11 8 10 12. That means we are missing the columns like passenger ID is not required, then survivor is our target variable, and we are taking from here P class. And then we are also not considering this cabin because it has almost 77% of missing values, and Ace has so 17% missing values, just roughly calculating. So we are selecting these columns, that means we are subsetting the data. Even after subsetting, the data frame has been created, so you have 891 observations and 8 variables. So you can just click on this to see the selected columns. So these are the selected columns. And one point to be noted is this gender column is having the values male, female. And as you know, no machine learning algorithm works with object type of data or string type of data. Even you can consider this embarked has the values like SCQ. So we have to impute them, we have to encode them. And age has missing values, so that's why we are filling the age value with mean here. So filling the missing values of age with mean, and then converting this gender column to factor type. That means we will be converting this into factor type, means we are going to have labels. So sex has two missing value, two unique values, so we are going to have 2 labels. Embarked has 3 unique values, so we are going to have 3 labels. And after that, so for missing values in the embark, so there are only two observations which are having missing values, so we just neglect them, we just remove those rows. So now you can see the number of rows are reduced here, 889. So earlier we were having 891, so 2 rows have been removed from embark. And then again we are checking the missing values by applying the sapply function. So once you run this line, you can see the missing values, the count or the sum of missing values is 0 over here. So we have removed the missing values, and then we are directly splitting the data into these values like 1 to 800, then 801 to 889. So you can follow up the other methods in splitting the data, like, so I'm just having like this, because here the number of samples are less, but when you have more number of observations, in that case this method does not work. So just we are manually considering the data set, the numbers, and then splitting. So you have to consider other methods when you have larger number of observations. So there is a method called as create data partition, so you can use that. And then here I'm building a model. GLM stands for generalized linear model, and this is an equation survived, then tilde operator dot means you are considering all the variables from your data. So data used over here is trained data, and family, the function family is binomial logistic regression. So the model is built, and then we are having a summary of the model. So summary is this: object trained data is not defined. Okay, I think I didn't run this, so I'm just running this, then building a model, then taking the summary. So this is the summary. So you can see that in the summary the coefficients beta 0 is 5.137627, and you need to observe the last column, so which no affects the term model. So better the value, better fitment, understand. So and also here you can note the null deviance and residual deviance values, and also AIC 727.37 is quite larger, right? So that is the summary of the model. And then from the test data again we are selecting these columns only, and then making the prediction by using our model. So predict of, that is the model, the new data is from test data, type is equals to response, and then displaying the header part of the data. So these are the prediction for the first few rows, like 801 the probability value is 75%, for 802 55%, here is 0.26, so this is going to be converted to 0. We set a threshold, right? If the probability value is greater than 0.5, we convert that to 1, or else we convert that to 0. So this is going to be 0, this is going to be 0, and this is also going to be 0, and this is also going to be 0, except the first two from these top rows. So here we are using if else. If the predicted value is greater than 0.5, consider that as 1, else 0, and then displaying the header part of the data. Now you can see the converted value is 110000. And then to plot a ROC curve, you can install this library ROCR, and then you can import, and then prediction, this is the predicted variable, and test data of survived. So from the test data you're considering this, and then performance is measure. So colorize equals true, measure is TPR means true positive rate, and x dot measure is FPR false positive rate, and you are showing a graph. So you can say this is the graph, so just like I have shown in my presentation PPT. So the more the area is more data is fitted, so the curve is going to be like this. And here based on the AUC value, area under curve, you can also evaluate your model. So I think it is going to result us the AUC value is 81.89, means 81% of the data is fitted to the model, right? So like this you can build a logistic regression model, and then you can evaluate your model. So you could also take some other data set and follow the same process. So generally we load the data and then check for the missing values, and most of the time we also do EDA. That we are not doing that. So our main objective is to build a model, logistic regression model, and then we have done the subset of the data, and then remove the missing values, and then now we have separated the data and then build a model here, and we have evaluated the model, and the submitted results are also there. And then we have plotted ROC curve, and AUC value we got is 81.89%. So this is about logistic regression. So do like us, do subscribe us for more relevant videos in near futures. So thanks for watching.